Right, let's get started. Good afternoon, everyone, and thanks for coming out to hear us talk about applications which are based on Linux and how do you do disaster recovery for them using Azure Site Recovery. My name is Siddharth Dikshit. I am a program manager on the Azure Site Recovery team. And joining me on the podium today is Sujay Talasila, who is a senior program manager on the Azure Site Recovery team. So let's get straight into it. We're actually going to start off with a demo. So I have a simple WordPress application here, which is running on two Linux VMs. There's a database VM and a web tier VM. And both of them are combining to deliver this application, which is located at 104.42.209.95, right? So this could be any application, right? This is just a dummy application for you, but it could be any N-tier application. Now, what I'm going to do is on stage, try to mimic an outage, right? And how I'm going to do that is by going to the individual virtual machines and actually shutting them. So I'm going to pick both the VMs, which are hosting this application, and I'm just going to stop those VMs. OK, so hopefully, in a few seconds, you will see that this application will be down. So I'm hitting refresh here. And you can see it's already down. It's trying to load, but it's down. So let's just give it a couple more seconds. Come on. OK, we'll come back to it. But basically, there you go. It's done, right? So I have mimicked an outage here by shutting down the VMs. And my VMs are Linux-based VMs, again, which are hosted in West US in a single resource group. And what I'm going to do now is trigger a failover of these VMs. Now, because we are doing a drill, I'm just going to do a test failover. So I have a recovery plan here where I have the two VMs, and I've sequenced them. And I'm going to trigger a failover. It's as easy as just clicking a couple of buttons. So I click on test failover here. Once I do that, I can select the recovery point that I want to failover to. And I can also select the VNet in which I can fail over to. So here I'm picking latest processed recovery point, and I can pick one of the VNets that I have and click on OK. And once I've done that, the failover starts. Now, this is going to take a few minutes, about 5 to 7 minutes. So we'll come back to it. And what I'll show you is I have failed over the VMs, and the application is now available in a different region at a different IP address. So I'll come back to that. So let's go back to our slides. So there are two key takeaways of this presentation. The first one is hopefully you'll get to see how easy it is to protect Linux-based applications. You probably saw that already, because within a couple of clicks and within a couple of minutes, I was able to start the failover operation. And I'll touch upon how easy it is throughout this talk. And then we'll also talk about how Site Recovery works closely with the major Linux distribution partners to bring support of all the latest releases as soon as possible. So again, I just want to double-click on the architecture of the application that I was hosting. So I had two VMs, a database tier VM, which was hosting MySQL, and a web tier VM, which was hosting Apache and WordPress. And I had them in West US. And with my drill, I'm failing them over to East US. What's going to happen is suppose there's an outage. We'll be able to bring up the database tier VM first, followed by the web tier VM. And then eventually we can access the application from the DR region itself. So I spoke to a couple of you just before I got on stage, and I understand that some of you may be new to Azure Site Recovery. So this is really the elevator pitch of what the product does, right? It's Microsoft's first-party DR solution. It allows you to replicate and fail over your applications on-premise or within Azure to an Azure region. So you could have your applications running in a VMware environment or Hyper-V environment, or they could be physical servers, or you could even use Azure Stack. Now, in each of these environments, you could fail them over to Microsoft Azure. Moreover, if you already are using Azure for your applications, you could fail over from one region to another. So if in the rare event that there is an outage, you can fail over your application and leverage a different region to host your application. We support both Windows and Linux, and I'm going to spend more and more time talking about Linux for the rest of this talk. But before I get there, I just want to quickly show you how easy it is to protect a VM using Azure Site Recovery. So I have a demo VM set up here in Azure. All I need to do is on the left-hand side blade, under Operations, go to Disaster Recovery. And what you see here is a map, right? So my application and my VMs were running in West US 2. And then this gives me the option to pick one of these regions where I want to enable my replication. So if you see the drop-down here, I can choose a number of different regions within this geographical cluster. So I'm just going to pick East US here, right? And you can just go ahead and review and start replication. So just a couple of clicks, and you're good to go. That's the simplest path. However, if you want to further change some of the aspects of your replication, such as your VNet or your resource group, you can certainly do that. So what you're seeing here is we've automatically populated the target fields for you. We are populating the VM resource group, the virtual network, your availability posture. But you can actually go back and review your replication, and you can also change it here, and you can start replication. So just a matter of clicks, and you can start the replicating, and your VM is protected within a matter of a few minutes. Can you go back? Thanks. Now, you may argue that any enterprise-grade application doesn't run on a single VM, right? You typically have multiple VMs spread across multiple tiers. And how do you configure disaster recovery for an application like that? You would ideally want to sequence the failover of your VMs to make sure that they are up and running in the disaster recovery region. And you also want to maintain the right order fidelity. You might want to add things like load balancers. You might want to do DNS routing. So there are a number of bells and whistles that you need to worry about when it comes to application-based disaster recovery. Now, to solve that, we have this concept of a recovery plan, which is a feature that allows you to sequence the failover of your virtual machines. It also allows you to integrate with Azure Automation runbooks. So in case you have any scripts that you want to run while you're orchestrating the failover, you can certainly do that. Moreover, you can also perform manual actions. So you can pause the run of your recovery plan, perform a certain manual action, and then resume it again. So this is a really neat tool which allows you to fail over your applications, which may be spread out over multiple tiers. So just as an example here, this is a SharePoint application for which I had set up a recovery plan. You can see that you have certain groups for your database tier and your application tier and web tier, and you can sequence them. You can also add scripts for your load balancers and any other custom scripts that you might want to use. And all of that can be sequenced, and just with a single click, you can start the failover of your application. Now, I promised that I'd talk about Linux, and what I'd like to share is that we support all major Linux distributions. It could be SUSE, CentOS, Ubuntu. If you're running SAP workloads, for example, maybe you use SUSE quite a bit. We support all major Linux distributions within 30 days. And if I can show you our support matrix, so if you go to our support matrix in our documentation, you can see the exhaustive list of all the kernels that we support. So you can see Red Hat, Ubuntu, CentOS, Debian, SUSE, you name it, and we have support for it. So I definitely encourage you to look at the support matrix in our documentation to see all the kernels that we support. This is just a support rollout perspective of what we've seen over the last quarter, I would say. So we had quite a few releases with all our major distribution partners. Red Hat, CentOS, and Oracle all came out with kernel 7.7. Red Hat went first in early August, and then CentOS followed in mid-August, and then Oracle came out with its 7.7 version in late August 2019. So how did we do? We were able to support Red Hat in early September. And by mid-September, we had support for CentOS and Oracle Linux already. So hopefully, this should give you a sense of how much time it takes. As you can see, it's 30 days or lesser for rolling out support. Now, if you're completely new to Azure Site Recovery, as some of you may be, a viable question would be, why does it even take 30 days, right? And the reason for that is there's a lot that goes on in the background. And to sort of understand what happens, I'll hand over the podium to Sujay.
Thanks very much, Siddharth. Let's look at what exactly happens behind the scenes when you use Azure Site Recovery. Let's take the example of a VM running in West US and you want to configure disaster recovery to East US region. When you configure Azure Site Recovery, ASR installs an extension component inside the VM, and ASR also creates the required target configuration such as VNet, resource group, subnets, etc. for your failover VMs to work. And then the initial replication of disks start. This is where we copy the entire disk from the source region and take it to the target region. And once the initial replication is complete, the ASR extension component that sits inside the VM keeps tracking any changes that are happening on the disks and transfers them to the cache storage account in the source region. From the cache storage account, the multi-tenant ASR PaaS service works behind the scenes to transfer the data to the target region, create recovery points that will be later used in the failover process. So this ASR extension component, which sits inside the VM, this has a filter driver component that tracks all the changes sitting at the disk filter layer. Because it sits at the core of the OS, it has a dependency on the OS kernel component. This is where things become tricky because there are a lot of Linux distributions that are endorsed on Azure. It's not just one distribution. And each of these distribution vendors follow a different release cadence. This makes a bit complicated for ASR to start supporting all the kernel updates that each of these distribution vendors release. So let me take a couple of examples to talk about this. Take the example of Red Hat Enterprise Linux. They follow the release cadence of major release, for example, 7, minor release 7.7, and they frequently release errata kernel updates. Whenever they release a kernel update, they also guarantee that there will not be any breaking changes, and any application that has taken a dependency on it continues to work fine. Because of that, whenever ASR certifies support for a major or a minor release, any kernel update that gets released later is automatically supported by ASR. Things sound simple and straightforward, right? Take the example of a different distribution, Ubuntu. Ubuntu follows the release cadence of 18, 18.04, and the free. Every 2 weeks, they release frequent updates, the kernel updates. But at the same time, they do not guarantee that any kernel update will not introduce any breaking changes. Because of that, ASR has to rebuild, recertify all the kernel updates whenever Ubuntu releases them. This is what takes time for ASR to release the certification. If you take about 6 months back, we used to take 60 to 75 days to support any kernel update released by the distributor. We have improved our release process. We have automated all the release mechanisms and certification process. Now we are supporting any kernel update within 30 days. That sounds great, but we want to make it even better. We want to start supporting any new kernel update from the time it's released. Let me talk about how we solve the problem with SUSE, how we are supporting SUSE kernels from day zero. SUSE, as you all know, is one of the common Linux distributions that are used by Linux applications running on Azure VMs. And a few months back, some of these customers reached out to SUSE saying that, hey, you're releasing frequent updates, but the disaster recovery on Azure is not supporting them fast enough. That's when SUSE team reached out to us, and we started collaborating with SUSE to ensure how to solve this problem and start supporting the kernel updates faster. How did we achieve it? We have handed over all the ASR symbols that are used and that are taking a dependency at the kernel layer, and we handed them over to SUSE. And SUSE guys whitelisted these components and ensured that whenever they release a new update, they are not going to break us. This ensures that any new kernel update from now, whenever SUSE releases it, it's automatically supported by ASR, as long as you are running a supported SUSE major or a minor version, any new kernel that's going to be released is automatically supported. To give you a perspective, a year back, we were taking about 75 days to certify any new kernel update. A month back, we were supporting it within 30 days for any SUSE kernel release. And now, we are supporting it from day zero. You don't have to re-update your ASR component to start supporting the kernel update. This is not just it. We are also working with all the major Linux distribution vendors to get early access to their major and minor versions so that we can start rolling out support from the day zero of their release. So this is how we are partnering with all the major Linux distribution vendors to release ASR support for them sooner and sooner. I'll hand the podium back to Siddharth to walk through the demo.
Yeah, thanks. So if you recall, I had shut down the VMs in my primary region and brought down the application at 104. If you can go back to the other screen, please. So this application was down, and I triggered the failover. Now I'm going to do something and refresh my DR region settings, and what you will see, hopefully, within a few seconds is that the application is up and running in the target region. So again, if I go back to my VMs, they are deallocated or deallocating. So the application is no longer running in my primary region, but there you go. It's back up in the DR region. So hopefully this should give you the sense of what you can do for your applications. Again, this was a super simple 2 VM application, a WordPress application on Linux. You can do this with any multi-tier application running on one of the Linux distributors that we listed, and you can have the same experience. Just a matter of clicks, and you can fail over successfully. So hopefully you were able to take away how easy it is to protect Linux-based applications with Azure Site Recovery, and also get a sense of how we partner with all the leading Linux distributors to make sure we support new releases faster and faster. So that's all from a presentation point of view. Just want to make a couple of call-outs. We are present on the floor, so if you move towards Theater 5, we are a few feet away. So come talk to us if you have any questions. We'll also be hanging around for a few minutes after. So if you have any questions, feel free to reach out to us. We also have a slew of new features and functionality announcements that are happening on Thursday. This should already be on your apps. You can register via your app as well. And we look forward to seeing you there. Another point, I already showed you some of our documentation when I was showing you our support matrix, but we have rich documentation which you can access via that link. We also have a white paper if you're just getting started of thinking about resilience on Azure. That white paper is probably your first port of call. We also have multiple how-to videos, and we have feedback forums as well, which you can leverage to reach out to us. So that's all from our side. We hope you found this useful, and we'll be here, and we can take any questions you may have. Thank you very much.
Thank you.